Okay, let's dive into this. Welcome to This Explainer. Look, if you've been using GitHub Copilot for your personal projects, you know it's basically magic. But trying to scale that exact same magic across a massive enterprise engineering organization, yeah, that is an entirely different beast. Today, we're distilling insights from a really comprehensive 30-chapter enterprise curriculum so we can finally move past just personal experimentation. We are getting deep into the architecture, the mechanics, and the master plan for a truly enterprise-grade Copilot deployment.
Here's our roadmap for today. We're going to cover why governance matters, the 5 customization pillars, file scoping, navigating those tricky IDE differences, enterprise repository structure, and we'll wrap up with an adoption roadmap and some best practices. Let's get started.
Section 1. Why Copilot Governance Matters. Or, how to scale your AI without total chaos.
We really need to talk about the catalyst for this entire discussion, which is the sheer pain of scaling AI without a solid strategy. Let me ask you this. Have you ever noticed that Copilot's output can be incredibly smart for one developer on your team, but then completely miss the mark for another person working in the exact same codebase? Why is it so inconsistent? Honestly, this is probably the most common organizational problem engineering leaders are facing right now.
Well, the answer is unstandardized usage chaos. When everyone just configures Copilot according to their own personal preference, the output goes wildly unpredictable. You end up with duplicated rules across repos, some instructions are way too broad, and developers are constantly confusing prompts with instructions. Plus, there's this massive and, frankly, dangerous assumption that however Copilot acts in VS Code is how it acts everywhere. Spoiler alert, it doesn't. To fix this whole shebang, we need to establish a golden rule of governance. Always use the narrowest mechanism that reliably solves the problem.
Moving on to Section 2, the 5 customization pillars. These are the 5 core concepts we absolutely have to nail. Now, to enforce that golden rule I just mentioned, developers need exact mental models of how Copilot is actually operating under the hood. What's really interesting to visualize here is the clear hierarchy. We don't just have some generic AI text generation bucket, we have a highly structured ecosystem of capabilities. We're talking instructions, prompts, agents, and skills. If your team doesn't understand the distinct purpose of each branch on this tree, your enterprise repository is going to become a massive mess of conflicting AI context in no time.
So, the biggest point of confusion is right here, instructions versus prompts. Let's contrast these directly, because it's super important. Think of instructions as the rules of the road. They are persistent guidance that tells Copilot, hey, work this way. They silently enforce your architecture and security standards in the background. Prompts, on the other hand, are active commands. They say, do this specific task right now, like generating a unit test or migrating an endpoint. Basically, instructions are always on, prompts are intentionally invoked by the developer.
Next up, we have skills. A skill is a specialized, reusable capability or procedure. Imagine you have this incredibly complex 500-line procedure for API development. If you stuff that massive block of text into your global instructions, you are literally polluting Copilot's context window on every single keystroke. No good. Instead, you create an API development skill. It relies on progressive disclosure, which just means Copilot only accesses that detailed procedure when it actually needs to build an API. It is infinitely more efficient.
Then we have agents. Take this architecture reviewer as a great example. Agents act as specialized AI workers or distinct personas. They aren't just passive rules. They have specific roles, assigned tools, designated AI models, and output constraints. When you invoke an agent, you are basically handing off a task to a specialized digital colleague, rather than just shouting into a generic chat window.
And a final pillar bridges the gap between what Copilot knows and what it can actually do. Knowledge is your internal context, the files and code sitting right there in your repository. But capability, that is unlocked through tools and the Model Context Protocol, or MCP, and it allows Copilot to reach outside the repository. This crosses a massive boundary, guys. It moves Copilot from just knowing about your code to actively interacting with external capabilities, like fetching a Jira ticket or querying a live database. It's a total game changer.
Section 3. File scoping and execution. Let's get into the syntax and the mechanics. Let's transition from all that theoretical taxonomy to the actual physical mechanics of customizing your repository. Take a look at a standard repository file tree. We've got our source files, API controllers, test services, all of that. Copilot relies heavily on exactly where files are placed in this directory structure to understand what context matters. But to govern this effectively at an enterprise scale, we have to explicitly set boundaries for how Copilot targets these directories.
And we set those boundaries using YAML front matters, specifically the apply to property. By setting apply to target your C# files, we are explicitly narrowing the scope of these coding standards so they only apply to that specific language. But listen closely to this. Apply to is an applicability mechanism. It simply tells Copilot, hey, if you happen to be working in a C# file, these rules are relevant. It is not a general-purpose prompt trigger that forces Copilot to immediately take action.
So the crucial point to remember here is this. Discovered does not necessarily mean active. Just because Copilot finds a Markdown file full of instructions sitting somewhere in your repository doesn't mean it automatically activates it and floods its context window. It dynamically evaluates relevance based on scope, location, and whatever immediate task the user is doing.
All right, Section 4, Navigating IDE Differences. It's time to bust the IDE parity myth.
Let's be real for a second. The IDE landscape out there is deeply fractured, and that requires some very careful architectural planning. This matrix totally dispels the IDE parity myth. If your team uses a mix of VS Code, Visual Studio, JetBrains, and Eclipse, you simply cannot assume that a custom agent or a specific prompt file is going to work seamlessly across all of them. The official support matrix changes constantly. As an engineering architect, you absolutely must not build your core mandated enterprise standards around a feature that is only supported by a single IDE. You have to design for the reality of the tools your team is actually using.
Section 5, Enterprise Repository Structure. Let's look at a scalable blueprint. Let's move into the blueprint phase and see what an actual scalable governance structure looks like in a realistic enterprise application file tree. Think about a complex .NET and Angular repo. Notice how cleanly everything is separated. We have a dedicated folder for our path-specific instructions, things like C#, Java, and specific testing rules. We have a completely separate prompts directory for code reviews and migrations. We have clearly defined our agents and nested our skills beautifully. Doing this keeps the Copilot context incredibly focused and completely prevents that unstandardized chaos we were talking about earlier.
And finally, Section 6, Roadmap and Best Practices. How to ensure safe enterprise adoption. So how does an engineering team actually adopt this massive structure safely without completely breaking their developers' current workflow? By following a strict adoption progression curve. You do not wake up one Monday morning and implement all 6 phases. Let me warn you right now, please do not jump straight to building complex custom agents and integrating MCP external tools. If your team hasn't even mastered basic global instructions yet, introducing autonomous agents is only going to create an unpredictable, noisy mess.
You really need to phase your rollout over time using a strict least privilege approach. Step 1. Establish basic, short global instructions. Step 2. Introduce path-specific instructions tailored to specific directories. Once those are stable and working, Step 3 is standardizing your reusable prompts. Only when your developers are actually comfortable invoking those should you move to Step 4, defining specialized skills, then Step 5, deploying custom agents, and finally, Step 6, hooking up MCP for that really advanced external automation.
Let's summarize the absolute fundamental governance rules here. First, keep your global instructions short to save that precious context window. Second, always use the narrowest scope possible. Third, never duplicate rules across files. Fourth, do not assume IDE parity. Always verify your team's environment. Fifth, assign tools using the principle of least privilege. And finally, treat all of this as actual engineering configuration, which means it absolutely must be version controlled right alongside your application code.
If you take absolutely nothing else away from this explainer, let it be this ultimate golden rule. Start with the smallest amount of customization that consistently improves Copilot output. Standardize your foundation first, and then specialize only where absolutely necessary. Seriously, do not over-engineer your AI.
So I'll leave you with this final, somewhat provocative thought. Take a look at your own code bases right now. Is your enterprise actively engineering its AI context using these structured pillars? Or are you just leaving Copilot's output up to luck, assumptions, and wild personal experimentation? It is time to take control of your AI ecosystem. Thanks for watching, and I'll catch you in the next explainer.